This is going to be 34-1. We're going to take a look at curve sketching. Now with curve sketching, we're basically going to be taking every single thing we've learned about the derivative in terms of how it looks like on a graph, and we're putting all the pieces together. And so because we understand the idea of concavity and inflection points, which is from our second derivative, and then, the idea of slope from our first derivative, we are able to find, those critical points and when their slope is 0, and so we can, take a look at our relative max and minimums. And then just from the basic algebra that we've learned in pre-calculus, finding the zeros, finding the x-intercepts, end behavior, things along those lines, we're actually able to take and put all of those together and be able to do this. Now, there's a tedious element about this, and it is a lot of work. I have done the best that I possibly could to try and condense the videos into short nuggets to where, if you were to actually do everything on hand, it's probably going to take upwards of 10 minutes. It could, but I'm hoping to try to condense this video as much as possible. Now, kind of some guidelines to help us sketch a graph. Think of it as like a list as we go through it. The first is to find the domain and the end behavior of the function. Find the x and y-intercepts of the function, the first derivative, relative extrema, and the intervals of increasing and decreasing, and then the second derivative, inflection points and concavity. So those are going to be the important pieces that we're going to want to look at. So on that first bullet point, find the domain and end behavior. Well, I know that because this is a polynomial, I know that the domain is going to be from negative infinity to positive infinity. So there's no vertical asymptotes, there's no horizontal asymptotes, and it's actually going to have this shape that looks like that. Now to find the x and y-intercepts of the function, for the y-intercept, we plug in 0 into our function. Now if I plug 0 into this, we're going to get 1, and so my y-intercept is going to be 0, 1. And then the x-intercepts, if you try your p's over q's, it's not going to be very successful. And so we're just going to skip that for now. To find what they're going to be more accurately, we're going to have to use a graphing utility or a calculator to be able to help us. Then the third bullet point, it says the first derivative, finding relative extrema and the intervals of increasing and decreasing. So that's what I did here. Now, like I said, I typed everything out so I can condense all of this onto one slide, but just kind of bear with me. I may skip some of the middle parts work, like the work that's in between, and I'm going straight to the pieces that matter. So I took the first derivative, and now I need to find those critical numbers. So then I set it equal to 0, and I factored it. And so I found my critical numbers to be 1 and 3. Now I don't have to worry about any undefined values, right, because it was a polynomial. And then the sign analysis, if I take my critical values and I put them on the number line, and I find the intervals of increasing and decreasing, so I plug in a value on this side, plug in a value in between, plug in a value on this side, I get positive, or increasing, decreasing, and increasing. Now because it goes from increasing to decreasing, this is a maximum. Because it goes from decreasing to increasing, I can state that this is going to be a minimum. So these are my relative max and mins. And then because I have a relative max at 1, if I take that value and I plug it into the very beginning, or to my original function here, I'm going to get 5. If I take 3 and I plug that in, it's going to give me 1. The last little piece here, the second derivative. So that means that you take the first derivative, which is what we have here, and we find the derivative of that again. And so when we do that, we get this. Now to find the value for an inflection point, set it equal to 0 and solve. And so I can determine where it's going to be concave up and down, and then also find that inflection point. And so because this value here, I got x equals 2, putting that on a sign chart again, testing a value on this side, that's going to be concave down. Testing a value on this side, I got positive, so it's going to be concave up. And then actually plugging that 2 into the very beginning, that's going to give me a 3. This right here is going to be my inflection point. So that is enough information. Now I can put everything together and sketch my graph. So my in behavior needs to follow this. My y-intercept is 0, 1, so I can put the dot there. My maximum or relative maximum is 1, 5. So at 1, 5 I have a relative max. Relative minimum, I have it at 3, 1, so I can put a dot right there. The inflection point is at 2, 3, so I know that's where it's going to change concavity. And if you notice, that says concave down and that says concave up. And so when I'm sketching this, following the in behavior, right, has to cross through my y-intercept. That is my relative max, so it's going to curve back down. And so this is right where the concavity changes, and so it's kind of hard to draw that actually in, but we just know that that's where it's concave down, and then now it's beginning to be concave up. And so here we go, we have it concave up, and that's going to be the sketch of my graph. And so that is curve sketching. So in conclusion, curve sketching is using as much information as possible to sketch the curve of the graph. If you remember from pre-calculus, we had very little information. We had the zeros, we had the y-intercept, and we had the in behavior. But now that we know calculus, or at least the concept of the derivative and the second derivative, we now can find the relative maximum and minimums within our polynomial or within our function, and then we can also find the inflection points so we can determine how it's going to, the concavity of our function, and if that inflection point actually represents that change in the concavity as it relates, vertical asymptotes and all this different stuff. So it just gives us more information to actually be able to sketch a graph properly. This does conclude our lesson. If you have any other questions, please leave them in the comments.